Okay, we're going to talk about ABGs. Now, the most important thing in order to understand ABGs is to memorize the parameters. If you do not memorize the parameters, you're just going to be in a constant state of confusion. Now, luckily, there's not that many parameters to memorize for the basics of ABGs. Um, our pH, of course, is going to tell us whether something is acidic or basic or within normal range. Our pH values, of course, 7.35 to 7.45. Anything lower than 7.35 is going to be acidic. Anything greater than 7.45 is going to be basic. So if we're acidic, our patient is going to be in a state of acidosis. If they are basic, they're going to be in a state of alkalosis. And I just drew this little vector line here. Put 7.4 in the middle because that's the ideal spot. That is the point of ultimate homeostasis. That's like homeostasis utopia right there at 7.4. From 7.4 to 7.35, which would be represented, let's make a little cutoff here. There's 735, let's say this is 745. Okay, within these range, we're still within normal range, but what I'm showing here is the further to the left of 7.4, we're getting more acidic. See, we're still normal. Once we cross this threshold here of 7.35 and go beyond that, we are in a state of acidosis. On the right side, 7.4, of course, the ideal utopian homeostasis. We keep going to the right. We are getting more and more basic. We're still within normal ranges, of course, all through here. And then once we cross this threshold of 7.45, we are in a state of alkalosis. Now, the two major things that affect our pH are going to be our PaCO2, which comes from our respiratory system, from our lungs, and our HCO3. This video is not going to get deep into the pathophysiology of this. What this video is more towards is to demystify some of the confusion as to what is respiratory acidosis or alkalosis or metabolic alkalosis or acidosis. What is partially compensated or uncompensated or fully compensated, because it all gets confusing. But if you memorize these parameters, you got to memorize, and there's not that much. Memorize these numbers, and it's going to be much easier for you. So our pH, again, 7.35 to 7.45, that's our normal range. To the left of it, lower than 7.35, we're acidic. To the right of 7.45, we're basic. Acidosis, alkalosis. PaCO2. Now if you take the 4,5 and the 3,5 from the pH, PaCO2 is pretty easy to remember. You just flip them around. Okay, so you're acidic with PaCO2 if you have greater than 45, and I'll put the units here for you, of course. This is millimeters Hg of mercury, and your HCO3 is milliequivalents per liter. Milliequivalents per liter. Okay, so our PaCO2 runs from 45, greater than 45 is acidic, less than 35 is basic. So between 35 and 45, or reverse it, between 45 and 35 is our normal range. And then our bicarbonate, which comes from where? The kidneys. The kidneys is what retains it and reabsorbs it, gets rid of it. Okay, that's our buffer here, our bicarbonate. The normal range is 22 to 26. Let me just put an L here for lungs. Okay, or respiratory. You can put an R if you want in your notes, it doesn't matter. So remember these numbers. pH, normal range, 7.35 to 7.45. That's normal. We're good. We're golden. PaCO2, okay, 45 to 35, normal range. HCO3, bicarbonate, 22 to 26, normal range. Now, we need to study and understand how these numbers all start affecting each other and how they affect the pH. Okay, the pH is what we need to look at most, the pH. Okay, so the golden formula is pH equals bicarbonate over PaCO2. Okay, and if you understand the way this formula works and you know these numbers, you really don't need anything else. I'm going to show you something else, but if you know these numbers and you know the way this formula works, that's all you need. So your pH is directly proportional to bicarbonate. If your bicarbonate goes up, your pH will go up. You see that? And of course, if your bicarbonate goes down, your pH will drop. They are directly proportional. So if they're directly proportional and we have a fractional representation here, what do you think your PaCO2 will do to your pH? If your PaCO2 goes up, what happens to your pH? It will go down, right? Because the greater the PaCO2H, the greater the PaCO2 divided into HCO3 mathematically makes this overall a lesser number. So PaCO2 up, pH down. And PaCO2 down, pH up. They're inversely proportional. Now, I saw a pretty cool video from Nurse Mendoza on YouTube. He made a little chart, and I thought it also made this easy to understand. I thought for people who maybe don't get this for whatever reason, maybe this will help it click. Because once it clicks, you realize this is really so much simpler than those crappy PowerPoints in school make it. I mean, the way these books write about it and the way they're presented in class is just, it's like this big mystery. And if you just understand it, learn your numbers, and then use a chart or a formula like this, it just all makes so much sense. So let's play with some numbers. So let's say we have a pH of 7.4. Oh, moving my thing here. Say we have a pH of 7.4. Let's say we have a PaCO2 of 40, and let's say we have an HCO3 of 24. Well, where are these going to fall? Our pH, normal. That's perfect. That's the holy grail, the utopian pH right there. That's perfect. Okay, PaCO2, 40, right in the middle. Oops, PaCO2. HCO3, our bicarbonate, right in the middle. HCO3. So this would be your, as far as acid-base disorders goes, this man or woman, this patient has zero acid-base disorders. Perfect balance, perfect homeostasis, right? So that's simple, and you're probably not going to see that on a test because there's nothing interesting about that. If you know the numbers, you would know that's all normal. So let's make them not normal. And let's see how we can figure out whether we have respiratory acidosis or metabolic acidosis or alkalosis or compensated or uncompensated. Alright, so first we're going to look at our numbers here. So let's say we have a pH of 7.25. Okay, and let's say we have a PaCO2 of 50. And we have an HCO3 of 24. So where does our pH fall? Well, if we remember the numbers, we'll be able to just plug it in right away, or we can look back up to our chart, and 7.25 is to the left of 7.35, which puts us into acidosis. So we're acidic on our pH. pH is acidic. What about our PaCO2? At 50, we are greater than 45, so we're to the left on this chart here, so we're in acidosis, we're acidic for our HCO3, I'm sorry, for our PaCO2, CO2, and then our bicarbonate is at 24, and of course that's smack in the middle. That is a normal bicarbonate reading, so bicarb is normal, HCO3. So what is this? Well, we know our pH is acidic, so we know this is some sort of acidosis. And what kind of acidosis? Well, what has caused us to go acidic? Our PaCO2, our respiratory system. We're retaining too much carbon dioxide. So this is respiratory acidosis. Respiratory. And our HCO3 is normal, so this is uncompensated. Because there is no, oops, sorry to move that screen on you. Uncompensated. There is no compensation. It's normal. It's not compensating for this out of whack PaCO2. So we have uncompensated respiratory acidosis. Let's do another example. Let me see if I do. I guess it's faster to erase. But I'll just continue this since I started it. Okay, let's get another example here. Let's say our pH is 7.15. Alright, our PaCO2 is 40. And our HCO3 is, how about 15? So, what is our pH? 7.15. We know that 7.35 is on the edge of acidosis. It's below that to the left, so our pH is acidic. pH goes under acidic column. And then our PaCO2 is right in the middle. So our PaCO2 is normal. And our HCO3 at 15 is below 22 in the acidic column. So our bicarbonate is acidic. HCO3. So, first thing we look at, pH, acidic. That tells us right off the bat, this is some form of acidosis. Acidosis. What else is acidic? How about our bicarbonate is in the acidic column. So this is bicarbonate is kidneys, not respiration. Kidneys, so it's metabolic acidosis. Metabolic acidosis. And our PaCO2 is normal, so it is uncompensated. Uncompensated. So we can see we have uncompensated metabolic acidosis. Alright, let's plug in some more numbers here. We'll do some more examples. The more you do this, the easier it gets. Alright, so let's do pH of 7.6. And let's say our PaCO2 is, let's call it 25. And our HCO3 is 24. Okay, So pH of 7.6 we know is basic, so we're alkaline for our pH. PaCO2 of 25 puts us to the right of the normal scale, so we're basic. So our respiratory, our PaCO2 is in the basic column, and our HCO3 is 24, which is smack dab in the middle right here. So our HCO3 is normal. HCO3. So what do we have? Well, our pH again tells us whether we're in acidosis or alkalosis, and because we're alkaline, we know it's some form of alkalosis. Alkalosis. And our PaCO2 is alkaline, so we know it is respiratory. Respiratory alkalosis, and there is no compensation because our HCO3 is normal, so once again uncompensated respiratory alkalosis. Make this bigger, get rid of this. And we're going to do another example here. That's my patch job. Okay, oh, I got to get rid of these numbers. Well, we can leave the pH there. I'm going to do another. We can change it around. We'll make it a little bit more interesting. Just keep you on your feet. So let's say 7 point. How about 7.5? And PaCO2 of 40. And let's say our HCO3 is 40. Okay, so what's going on here? Our pH. Hopefully you've memorized these numbers by now. 7.45 is the edge. I'll just show it to you again just so you can see. So 7.5 puts us to the right of 745, which is basic, right? So our pH is going to be alkaline. PaCO2 of 40 is right in the middle, so that's within normal limits. And our HCO3 is 40. And where does that put us? That puts us way, way, way over here in the basic category. So we actually probably would have been a little more alkaline with the HCO3 off like that. Yeah, I mean, it's probably an extreme right there, but let's just say, I don't know, 7.8. These numbers are just for demonstration purposes. They don't reflect what an actual proportional lab value is. It's just used to show you how to figure this out, because it'll work with the right numbers. So we're still basic with our pH. Our HCO3 is way off the charts to the right, and that's of course alkaline. HCO3. So again, we have some form of alkalosis, because our pH is alkaline. Alkalosis. And we see we have our bicarbonate is alkaline, which is kidneys, which is metabolic. Metabolic alkalosis. And our PaCO2 is normal, so it is uncompensated. There is no compensation. So we have uncompensated metabolic alkalosis. And if you make yourself one of these charts, you can just come up with your own numbers. That's what I'm doing here. I'm just making up numbers, and they'll work for you. It'll help you understand this basic concept. So let's get into a few more examples. Let's do some a little more interesting. Let's say we're at a pH of 7.1.15. Let's put our PaCO2 at 50. Let's say 55, and then our bicarbonate we'll say is let's say it's 29. Okay, so where's our pH? 7.15, of course, is less than 7.25, so we are definitely acidic. pH. And right off the bat, you know, if we're acidic with our pH, then we're looking at some form of acidosis. Now we just got to figure out what kind. Our PaCO2 of 55 is acidic. Just to show you, we are well to the left of this 45 mark, which is the cutoff for normal. So our PaCO2 is acidic, and our bicarbonate at 29 is also not within normal range, but it's to the alkaline side. It's to the right of 26, right? So our bicarbonate is alkaline, HCO3. So this is interesting. So how do we categorize this? What do we call this? Well, we know we're acidic. Our pH is 7.15. Okay, so we have acidosis. So what else is in the acidosis column? What has caused us to go towards the acidic column? What has made us become acidic? Well, the PaCO2. We're retaining carbon dioxide through whether it's hypoventilation or some sort of COPD or emphysema or what have you. We are retaining carbon dioxide, and we have caused our body to become acidic. So this is respiratory acidosis. Just like before, respiratory acidosis. But our HCO3 is also not normal. Our HCO3 is alkaline. So why is it alkaline? It's because our kidneys are trying to compensate for this this acidic process going on. The kidneys are trying to buffer this acidotic state that we're in. So this is the kidneys are compensating, but nothing is in normal range. So they haven't fully compensated. They haven't brought us back into homeostasis, but they're trying. So this is partially, that's misspelled, isn't it? Partially compensated. Partially compensated respiratory acidosis. Okay, let's do sorry for my spelling. Let's do another example. Okay, let's leave our pH there. Let's just switch these around. Boom. Let's say our PaCO2 now is 45. I'm sorry, that's not what I want to do. Let's say our PaCO2 now is 25, and let's say our bicarbonate is 15. Okay, so our pH is again acidic. Our PaCO2 is basic, you see here, because it's to the right of our normal here. We're less than 35, which puts us basic, so we're alkaline for our PaCO2. And our HCO3 at 15 is, of course, acidic. It's to the left of 22, okay? HCO3. So, where are we? How do we categorize this? Well, pH is acidic, so we know we're dealing with acidosis. And this is bicarbonate from the kidneys, metabolic acidosis. And we are again, nothing's in normal range. The Our lungs are trying to get rid of that carbon dioxide. They're trying to become more alkaline to offset this acidic process going on here. So we are partially compensated. Partially compensated. Partially compensated metabolic acidosis. Okay, so you see how that works? And then it'll work the same way. I think you should be able to catch on by now. If we were in if we had an alkaline pH, say 7.6, okay, and say we had PaCO2 of, I don't know, again we'll say 25, and an HCO3 of, let's say, 18. Okay, so our pH at 7.6 is alkaline. Our PaCO2 at 25 is also alkaline. PaCO2. And our HCO3 at 18 is acidic. HCO3. So, pH is alkaline. We know it's alkalosis. PaCO2, respiratory, and nothing's in normal ranges. Our HCO3 is trying to offset this. It's compensating, but not completely. So again, partially compensated respiratory alkalosis. And we'll do another example. One more partial example here of the partially compensated, and we'll move on to fully compensated. Okay, so once again, let's say our pH is 7.7. Let's say our PaCO2 this time is 50, and our HCO3 is 30. Okay, so pH of 7.7, that's going to be alkaline. Right off the bat, you know we're dealing with alkalosis because our pH is alkaline. Alkalosis. Our PaCO2 is 50, and that is going to be to the left of our chart here. Okay, so we're to the left of 45, so we're acidic on our PaCO2. PaCO2. And then our HCO3, our bicarbonate, is 30, which is going to be to the right of the normal range. Bicarbonate is to the right. So we are alkaline too as well for our bicarbonate. HCO3. So we're alkaline bicarbonate. We know we're alkalosis. We have metabolic alkalosis. Nothing within normal ranges, but our PaCO2 is on the opposite side of the scale trying to compensate. So we have partially compensated metabolic alkalosis. Okay. Now let's get into a last set of examples here that I want to do, and I think you guys will have a pretty good understanding of how to do this if you don't already. Okay, So let's give ourselves a pH of 7 point, let's just put it right on the edge. Let's put 7.35, okay? Oh, let's not make it that easy. We'll make it a little bit harder than that. Okay. Let's say we are at 7.37. How about that? And then let's say our PaCO2 is 45. And then our HCO3 is 26. Oh, we gotta get out of normal ranges. Let's say our PaCO2 is 48, and our HCO3, let's say, is 27. I need to do better than that. Let's just go ahead and put us up at 50, and let's say 28. How about that? Okay, so pH is 737, which is within the normal range. But where is it within the normal range? 7.4 is here, 735 is here, so 737 is somewhere in here. Oops, didn't want to do that. 737 is somewhere in here. It's probably right about there. So we see, while we're normal, we're to the acidic side of normal. Alright, so just keep that in mind. We're on the acidic side of normal. Acidic. Normal, but it's towards the acidic side. And then our PaCO2 is 50, which is to the left of 45, and we know 45 is the borderline of normal to the acidic side. So our PaCO2 is acidic. And then our HCO3 is 28, which is to the right of 26, which is to the base. So we have alkaline HCO3. So what is this? This is, we can call it acidosis. Acidosis. And our acid is coming from the PaCO2, so it's respiratory, but it is fully compensated. Fully compensated. It's being fully compensated by the HCO3. See that? This is fully compensated respiratory acidosis, where our pH is in normal range. Our body is keeping homeostasis, but it's doing that by recognizing that our PaCO2 is acidic and buffering it with the HCO3. Okay. Let's do another example. We have a pH of 7 point, let's say 7.47. Alright, and then we'll do a PaCO2 of, let's say 50 again, and an HCO3 of, let's just change it around, HCO3 of 29. Alright, so we have pH of 747, of course, is normal, but now we're on the right side of normal, on the right side of the range. Okay, so we're heading towards that 745. Oops. Sorry about that. 743. So we're over here. 4, 3. Okay, so we're in the basic side. So our pH is normal, but heading towards the basic. Okay, our PaCO2 of 50 is of course to the left, so that's acidic. And our HCO3 is normal, but it's to the right, is not normal, it's to the right of normal, to the alkaline side. So HCO3 is alkaline. So we know that our pH is normal, but leaning basic. So this is an alkalosis. Alkalosis. What is pulling it to the alkaline side? HCO3, bicarbonate. So we're metabolic, and our lungs are compensating for this. So it's pulling us. Our lungs are compensating for this this body trend to go basic by making our body more acidic by holding on to CO2. So this is fully compensated metabolic alkalosis. And then you can play with the values again, and you can make it fully compensated metabolic acidosis, fully compensated respiratory acidosis, respiratory alkalosis, etc. But I hope at least by watching this video, you've gotten the idea, and just do this for yourself. Make your own video. The best way to learn is to teach, and hopefully this helps. Thank you very much.